Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this lesson is about integration of the expressions of the form ax plus b to the power n, meaning we are given the linear expression here ax plus b, which is a linear expression as x has the power 1, and then this linear expression ax plus b is raised to any high power, which can be an n here. So let's see how we can integrate the linear expression raised to the power n. So integral of the linear expression ax plus b to the power n with respect to x dx shall be equal to ax plus b. Now this ax plus b, as we always go for adding a 1 to the power, it becomes n plus 1. And then in the denominator, I shall be having the differential of the function, the linear expression ax plus b times n plus 1 here, times n plus 1. We know in integration we always divide the expression by n plus 1. So it's also getting divided by n plus 1 and then adding the constant c. So this means that the integral, the answer to the integral function here shall be ax plus b to the power n plus 1 divided by the differential here is an a times n plus 1 and then add the constant c here, provided that our n is not equal to a negative 1. And we know the reason. If I substitute n with a negative 1, the denominator becomes 0, and any number divided by a 0 is an undefined function. So here we should be having the condition that n should not be equal to a negative 1. So this is how we can go for the integration of the linear expression raised to the high power n. Let's start working on some examples. So the first example here is to find the integral of 4x minus 5 to the power 5. It's 4x minus 3 to the power 5 dx. So what we can do here is to 4x minus 3 to the power 5, I should be adding a 1, and then in the denominator I should be having the differential of 4x minus 3, and then I should be multiplying it by 5 plus 1, which is a 6 here, and add the constant. So here I can say that my answer for this integral function is 4x minus 3 to the power 6 divided by the differential of 4x minus 3, which is a 4, times 5 plus 1, that is a 6, and then add a c here. So it's 4x minus 3 to the power 6 divided by 4 times 6, which is a 24, and then add a c here. So this is then going to be the answer to this question. Let's do another one. Find the integral of 15 divided by 2 minus 3x raised to the power 6 dx. So basically they are asking for the integral of 15 divided by 2 minus 3x to the power 6 dx. So what I can do here is I can take this 15 outside the integral sign, and then I can take the denominator 2 minus 3x to the numerator by changing the sign of the power and then integrating it. So here what I can see is that it is a 15 times 2 minus 3x, and to this power, which is a negative 6, I should be adding a 1, and at the same time I should be dividing it by the differential of 2 minus 3x, and then I should be dividing it also with negative 6 plus 1, which is a negative 5, and add a constant here. So meaning in this case my answer is going to be 15 times 2 minus 3x to the power negative 5 divided by, now the differential of 2 minus 3x is just going to be a negative 3. Differential of 2, the constant, it gets eliminated. Negative 3x gives me a negative 3, and then I should get get this multiplied by a negative 5, and then it should be a positive c here. So here it's a 3 times 5, negative 3 times 5, which shall give me a 15. And then it's 2 minus 3x to the power negative 5 plus c. And further I can say that this 15 here gets simplified, and then I should be having 2 minus 3x to the power negative 5 plus c, or further I can say that my answer in positive index form is 2 minus 3x to the power 5 and a plus c. So this is then going to be the answer to this integration question. Let's do another one. Question 3, find the integral of 3 times square root of 1 minus x dx. So to integrate this, I shall take the constant outside the integral, and then here I can say it's 1 minus x to the power 1 by 2 dx. And then to integrate this, it should be a 1 minus x to the power 1 by 2 plus 1. And then I should say it's the differential of 1 minus x, and 1 by 2 plus 1, which gives me a 3 by 2, and then I should be adding this constant c here. So this means my answer, the integral, is going to be 3 times 1 minus x to the power 3 by 2. The differential of 1 minus x shall be just a negative 1 and then times a 3 by 2. So here again, and then obviously plus c. So here again, I can see that this is a negative 3 times 2 divided by a 3 here. I've just taken the negative from the denominator to the numerator, and then this 3 by 2, it's getting reciprocated so that this becomes a 2 by 3 here. And then I should be having 1 minus x to the power 3 by 2 and then a plus c. The 3 gets simplified and I will be left here only with negative 2 and 1 minus x to the power 3 by 2 and plus c. This is then going to be the answer to this question. Question 4 says, find the integral of 6 divided by square root of 6x minus 5 to the power 3 dx. So to work on this question, I shall be taking the 6 outside the bracket, and then I'll be left here with 1 divided by 6x minus 5, which has a cube to it, and then square root means that there is the outer power, which is a 1 by 2 and dx. So further I can say that this is basically the integral of 1 divided by 6x minus 5 to the power. Now we know that power to power, like if I have the power which is a to the power x to the power y, or first let's solve it with a y. I know that the power to power gets multiplied so that I can say that this is a to the power xy. In the same manner, if you have ax to the power 1 by y, then I can say that this is ax times 1 by y, or also I can say that this is ax to the power a to the power x divided by y here. So in the same manner, I can say this is 3 times 1 by 2 dx, or further I can say that this power is a 3 by 2. So basically I'm here to integrate 6 integral of 6x minus 5 to the power 3 by 2 and dx. So further, I can say that taking the denominator to the numerator, it's 6x minus 5 to the power negative 3 by 2 dx. And now I shall be integrating this function, so that I should say that this is 6 times 6x minus 5 to the power negative 3 by 2 and a plus 1. Negative 3 by 2 and a plus 1, that gives me a negative 1 by 2. So I shall say it should get divided by the differential function of 6x minus 5, which is basically a 6. and then it should be n plus 1, which is giving me a negative 1 by 2, and then I should be having a plus c here. So this means that this function is basically for 6 into 6x minus 5 to the power negative 1 by 2, and then this should get divided by the differential of 6x minus 5, which is just a 6, times a negative 1 by 2, and then a plus c. So what I can see here is that the two sixes, they get simplified. Negative 1 by 2, I can just reciprocate this negative 1 by 2, making it a 2. And then it's 6x minus 5 to the power negative 1 by 2 and a plus c. This can be the answer, or further writing it as a positive index, I can say that this is a negative 2, 6x minus 5, the square root, 6x minus 5 the square root, and then it should be a plus c. So both of them, they can be the correct answers to the integral of 6 times 6x minus 5 to the power negative 3 by 2 here. So this is then going to be the answer to this question. Find the integral of 4 divided by 1 minus 2x to the power 7 dx. So again, I shall be taking the 4 outside the integral sign. 1 minus 2x taken to the numerator becomes a negative 7 dx. So this is the function which I need to integrate. Therefore, I should say it's 4 times 1 minus 2x minus 7 plus 1. That should give me a negative 6. And then I'm doing it directly now. The differential of 1 minus 2x, that will give me a negative 2. And then I should be dividing it by n plus 1, which gives me a negative 6, and then it's a plus 6 here. So this here becomes 4 divided by negative 2 times negative 6, which gives me a 12. And then here it's a 1 minus 2x to the power negative 6 plus c. Solving 4 and 12, that gives me a 1 by 3. So I should say that this answer then is going to be a 1 by 3, 1 minus 2x to the power 6, and then a plus c. So this is then going to be the answer to this question. So one more example to solve for composite integrals. Let's say it's the integral of the square root of 2 plus 3x, and this is whole to the power 5 and dx. So this complicated as it seems, but it's going to be very simple. If I can simply say that this is a 2 plus 3x, square root means it's to the power 1 by 2, and then further we had the bracket which had the power 5. Again, we know that power to power, they get multiplied. So I can say it's a 2 plus 3x to the power 1 by 2 times 5, that would give me a 5 by 2 dx. And then it's the same process that we need to continue with. So here we can say that this is a 2 plus 3x to the power 5 by 2 plus 1 divided by the integral of, by the differential of 2 plus 3x. That would give me a 3. And then I should be having a 5 by 2 plus 1. So 5 by 2 plus 1, that should give me the answer as a 7 by 2. So I can say that here I should be having a 7 by 2 and then adding a constant c here. So this means that my answer to this question is going to be 2 plus 3x to the power 7 by 2 divided by 21 by 2 and then a plus c. Further simplifying 21 by 2 in the denominator, I should say it's a 2 divided by 21, and this is going to be a 2 plus 3x to the power 7 by 2 and a plus c. Or if I want to further write it as the radical sign, then I can say that this is a 2 plus 3x, and this is whole to the power 7 and a plus c. So this can be the answer to this question now. Now we shall be going for some word problems to get more understanding of the topic. So find f of x if f prime x equals, so let's write it as f prime x, which is equal to 1 over 5x minus 3 to the power 4. So what we know here is that f prime x is equal to 1 over 5x minus 3. F prime x actually gives us the first derivative or the differential function. So if they are asking for f of x, then that means they are asking us for an equation which is in terms of x. So that can be the equation of the curve. So that means I need to integrate this f prime x first. So if I integrate this f prime x, I need to integrate this f prime x. So integrating both the sides. The integral of f prime x is going to be an f of x. The integral of f prime x is going to be f of x. And then here I can say that I shall be having the integral of 5x minus 3 to the power negative 4 dx. So solving that, we know that to the power 5x minus 3 to the power negative 4, I shall be adding a plus 1, and then denominator, I should be differentiating 5x minus 3. The differential of 5x minus 3 gives me a 5, and then I should be multiplying it by n plus 1, which in this case is a negative 4 plus 1, giving me a negative 3, and then adding a constant here. So this is going to be my f of x in this case. So here I can say that my f of x here is going to be a negative 1 by 15 and a 5x minus 3 to the power negative 3 and a plus c. Or further, I can say it's the f of x, which then is equals to a negative 1 by 15, 5x minus 3 to the power 3 and then a plus c. So there is one condition which is given in the question, and that condition says that f of 1 is equal to negative 90. F of 1, it equals negative 90 here. So f of 1 equals negative 90. I shall write the condition here. It's f of 1 which is equals to a negative 90 here. So this means that in this condition, if our x is going to be a 1, if our x is a 1, then the whole function shall be equal to negative 90. So that means our f of x equals 90, therefore it's negative 90 here, which shall be equal to negative 1 divided by x value here is a 1. So I will be substituting x with a 1 and then a negative 3, the whole cube and a plus c. Further, I can say that this is going to be a negative 90, which then shall be equal to a negative 1 divided by 15 times 5 minus 1, that gives me a 2, and 2 the whole cube and a plus c. So to find this c value, I can, so it's going to be a negative 90 plus, I'm taking this term on the left side so that this becomes a positive. So here it is 1 plus 1 divided by 15 times 2 the whole cube, and 2 the whole cube gives me an 8, and then this should be equal to the c value. So solving it, I can say that my f of x is going to be a negative 1 divided by 15 times 5x minus 3 the whole cube, 5x minus 3 the whole cube, and approximately a negative 90 here. So this is going to be the function equation in terms of x with respect to this question. Let's do another one. So this question says that d2y over dx squared, the second derivative, is equal to 1 by 4x plus 1 the whole to the power 7. And they have given us certain conditions, and they are saying when x is equals to 4, it's dy by dx, which is equals to 6, and when x is equal to 4, our y is equal to 0. So there are two conditions that they have given us for x value to be 4. It's the gradient, which is a 6, and then and that is also possible, so that when x is a 4, the y coordinate is a 0. So find y in terms of x. And they have started the equation with respect to the second derivative. So as discussed earlier, we know that in integration, We know that in integration, it's the reverse process of differentiation. Therefore, I shall be integrating the second derivative d2y over dx square to get our integral, to get our dy by dx, which further, when integrated, shall give us y in terms of x. Y in terms of x here. So these are the two steps that we should be following here. I should be first integrating d2y over dx squared to get the gradient equation, and then that gradient equation shall again then be integrated to get y in terms of x. So let's start working on this topic. So we are given here d2y over dx squared, and this is equal to a 1 by 4x plus 1 and the whole to the power 7. So I should be integrating this function. So if I integrate the second derivative, I know I should be getting the first derivative dy by dx, which then shall be equal to 1 by 4x plus 1, and this is whole to the power 7 plus 1. Add 1 to the power, and then it should get divided by the derivative of 1 by 4x plus 1, which gives me a 1 by 4, and then into n plus 1, which in this case is a 7 plus 1, giving me an 8, and then there should be a constant added to it. So I'm adding the constant as a k value here. So here this 4 and 8, they shall get simplified. I can say it's 4 ones are and then 4 twos are, so that my first derivative equation, that becomes dy by dx, which can be equal to a 1 by 2 and a 1 by 4 x plus 1 to the power 7 plus 1, giving me an 8 and then a plus k. So to find this value of k, so to find this value of k here, they have given us the condition. They have said when our x is a 4, they have said when our x is a 4, our gradient value dy by dx equals 6. So with this value, our x equals 4, this condition is given. X equals 4, our dy by dx value is a 6. So I shall be substituting the two conditions here. Dy by dx is a 6, and then this becomes a 1 by 2 and 1 by 4 times x value being a 4, and then plus 1 to the power 8 and then plus k. So again here I can see that the 4 gets simplified, giving me a 1, and I should say it's a 6, which is equals to a 1 by 2 times 1 plus 1, which is a 2 to the power 8 and then plus k. So this 2 and 2 to the power 8, I can simplify that, and I can say that this is basically going to be 2 to the power 7, and 2 to the power 7 shall give me 128 and then plus k here. So k value then is going to be a 6 minus 128, which then shall be equal to a negative 122. Dy by dx here, my dy by dx here is going to be a 1 by 2 times 1 by 4x plus 1 to the power 8, and this k value substituted, this becomes a negative 122. So I have obtained from the second derivative the first derivative or the gradient equation for this curve. Now we were asked to get y in terms of x, and therefore I shall be integrating this again to get our y in terms of x. So integrating it again, I should say that this is going to be the integral here. So dy by dx, this becomes the integral of dy, which then shall be equal to the integral of 1 by 2 and a 1 by 4 x plus 1 to the power 8 negative 122 dx. So integrating this function, what I can see here is that this is a 1 by 2. So 1 by 2 over here, and then to the function 1 by 4x plus 1, I to the power 8, I should be adding a 1. And then we know that we have to differentiate 1 by 4x plus 1, giving us a 1 by 4 times 8 plus 1, which gives us a 9. And then it's a negative 122x. The integral of 122 is a negative 122x, and then it should be a plus c here. So with that, what I can see here is that I first need to explain this function here. This is basically 1 by 2 into 1 divided by a 9 by 4. So I should be reciprocating this function so that 1 divided by 9 by 4, our 4 should go to the numerator, giving us a 1 by 2 into a 4 by 9. And simplifying 2 and 4, I can say that my answer here is a 2 by 9. So meaning the simplification of 1 by 2 into a 9 by 4 is basically a 2 by 9 times 1 by 4x plus 1 to the power 9 and negative 122x plus c. So this is the y equation in terms of x, but then I need to have the value of this c also. So to get the value of this constant c, I shall be using the condition which was given in the question, and that condition was when x is equals to 4, our y was equal to 0. So I will be using this condition to find y in terms of x. So when x equals 4, our y equals a 0. Substituting y as 0 and x as a 4, I shall be getting here 2 by 9 times 1 by 4 into 4, which gets simplified as a 1. And then it's going to be a 1 plus 1. Here it's going to be a 1 plus 1, that gives us a 2, and 2 to the power 9 minus 122 into 4 plus c, which gives me a negative 488 plus c here. So 1 plus 1 is a 2, and this is 2 to the power 9. 2 by 9 into 2 to the power 9 minus 488 plus c. So I would want to revise or explain this index identity, which says that if there is a common base, a to the power x times a to the power y, then with this a base as common, I can say that the two powers, the two indices, they get added with each other. So that it becomes a to the power x plus 1. In the same manner, for 2 to the power 1 into 2 to the power 9, I can say that this is 2 to the power 1 plus 9, giving me 2 to the power 10. So 0 then shall be equal to 2 to the power 10 divided by 9 minus 488 plus c. Further, I can say that solving this, it becomes c, which is equals to 488 minus 2 to the power 10 divided by 9, which gives me 3368 divided by 9, or I can say it's a 374.22. So y in terms of x, I have the value of the c also, which is a 374.22. So y then shall be equal to a 2 by 9 times 1 by 4x plus 1 to the power 9 minus 122x plus 374.22, and this is going to be the equation for y in terms of x, or we can say that this is actually the curve equation for the given second derivative. So this is how then these equations shall get solved. And let's end the topic here, and we shall be meeting again in the next video regarding the next topic of integration, which is going to be our definite integrals. So take care and best wishes. Allah Hafiz for now.